Section 8.4, Lagrange multipliers. In this section, we are going to apply the method Lagrange multipliers to solve constraint optimization problems. Local extrema for a function z equals f of xy. We consider the problems of locating the maxima and minima of functions of two variables in which there are certain restrictions or the site conditions on the variables. The problems are known as constraint optimization problems. One general method for finding maxima or minima of functions when there is a constraint on the variables is the method of Lagrange multipliers. In this method, the Greek letter lambda is used to represent a variable called the Lagrange multiplier. This technique is based on treating lambda as an independent variable and forming the Lagrange function. Use notation capital F as a function of the x, y, and lambda consists of the f of xy given by the problem plus the lambda multiplied by the gxy, which is the constraint given by the problem. The method of Lagrange multipliers. To maximize or minimize a function z equals f of xy subject to the constraint gxy equals 0. Step number 1, we're going to form the Lagrange function, the capital F equals the function xy plus the lambda times gxy. Note that the gxy, make sure that the other side is 0. You have to rearrange it until you get in the form of the expression equals 0, and the expression is the g of xy, or the constraint function that we used in the Lagrange function. Next step, or the step 2, we're going to find the first order partial derivative with respect to y, with respect to x, with respect to lambda, respectively. And then step number 3, we're going to solve the following system of 3 equations. The partial derivative with respect to x equals 0, the partial derivative with respect to y equals 0, the partial derivative with respect to lambda equals 0. And step number 4, if f has a local maximum or local minimum subject to the constraint gxy equals 0, then the corresponding x and y values will be found among the solutions to the system in step number 3. Let's take a look at the example. In this example, we're going to use the method of Lagrange multipliers to find the minimum value of function f subject to the given constraint. The function fxy is 2x squared plus 3y squared minus 2 times xy, subject to 3x plus 4y equals 332. What we need the function fxy, yes, and we need the function gx, which is the constraint. The constraint gxy, recall, is in the form of the expression equals 0. So therefore, for this case, the gxy is in the form of 3x plus 4y minus 332. And then let's start with the step number 1. Step number 1, we're going to form the Lagrange function, which is the function, the capital F, as a function of x, y, and lambda, formed by the f of xy plus the lambda multiplied by g, it's lambda multiplied by gxy. The function that we have is 2x squared plus 3y squared minus 2xy plus the lambda multiplied by 3x plus 4y minus 332. Step number 2, we're going to find the first order partial derivative with respect to x, with respect to y, and with respect to lambda. For the partial with respect to x, we're going to treat x as the variable. The rest going to be treated as a constant term. X here, we see x right there, we see x right there. Therefore, the first order partial derivative with respect to x is gonna be 4x minus 2y plus 3 lambda. And similar to the partial derivative with respect to y, we're gonna look at y as the variable. The rest gonna be treated as a constant. So the partial derivative with respect to y is 6y minus 2x plus 4 times lambda. And then the partial derivative with respect to lambda. We look at lambda as the variable, the rest gonna be the constant. Then we're gonna get 3x plus 4y minus 332. Then we move on to step number 3. By solving the system f x equals 0, f y equals 0, and f lambda equals 0, for the first order partial derivative with respect to x, with respect to y, with respect to lambda equals 0, respectively. So for the first one, which is the 4x minus 2y plus 3 lambda equals 0. Second one, 6y minus 2x plus 4 lambda equals 0. And the last one, 3x plus 4y minus 332 equals 0. We're going to solve these three equations simultaneously to find the x and y that are defined. The tip of this one is to eliminate or to find the notation for the lambda and then use the lambda to find x and y. So the two equations containing lambda would be the first one and the second one. We're going to start with solving for lambda for the first equation. So we have 4x minus 2y equals negative 3 lambda, or the lambda equals 4x minus 2y divided by negative 3. The second one, similar way, 6y minus 2x equals negative 4 lambda, or the lambda equals 6y minus 2x all divided by negative 4. And since both of them are the expression for the lambda, we just equate them. We get 4x minus 2y divided by negative 3 equals 6y minus 2x divided by negative 4. At this point, the lambda is gone. We're gonna solve for either x or solve for y. So for our convenience, I'm gonna look for the y in terms of x. First of all, cleaning up the denominator, like doing by cross multiply. Before we cross multiply, let's take away the negative side here. And then cross multiply, we have 4 times 4x minus 2y equals 3 times 6y minus 2x. And then expand them out to be 16x minus 8y equals 18y minus 6x. And then write y in terms of x. I'm gonna collect the y term in one side and x in the other side. So add 8y both sides to be 26y, and then plus 6x both sides to be 22x. So then the y is 22x divided by 26, which is in the simplified form as 11x over 13. And after we get y in terms of x, we're gonna use it in the last equation in the system. So replace the y with the expression 11x over 13, and we get 3x plus 4 multiplied by 11x over 13 minus 332 equals 0. And then simplify and solve for x. We got 3x plus 44x over 13 equals 332. And then collect the terms here. 3 as 3 over 1, so going to be 39x over 13 plus 44x over 13 equals 332. 39x plus 44, that is 83x over 13 equals 332. Simplify further to get the x. So x equals 332 multiplied by 13 divided by 83. At this point, we will get the x equals 52. After we get x equals 52, we replace the x with 52 to solve for y. So y equals 11 multiplied by 52 divided by 13. We can see that 13 goes to the 52 like 4 times. 4 times 11 is 44. Now we got the x and y value. That's what we're looking for. X equals 52. Y equals 44. To give the optimized value for this function with the given constraint. And you see the given answer, we are in the right direction. So we are looking for the function value at, let's see, let's clean up. So the function value at 52, 44. We go back to the given function, and the given function is 2 times x squared. Now it's 52. Plus 3 times y squared, which is 44. Minus 2 times x times y. 2 times 52 times 44. The answer should come out as 6,640 as designed.